All right, so we're going to move on and continue on with Unit 1, which is going to be learning targets 10 through 17 as a focus today. And it's going to deal with science and practice. A lot of vocab in these learning targets, so be sure if you are taking notes or you're going back to rework on your notes that you be sure you're getting all the vocab terms. All right, so in science, any type of science, there are three major assumptions, and that's what we're going to start with. The three major assumptions of science. Number one, first assumption is that there are natural causes of natural phenomena. And there's that word again, phenomena. Anything in nature can be explained by natural as opposed to supernatural causes. A phenomena is an observable fact or event. It is the job of science to answer questions concerning things in nature. Okay, so scientists are concerned with finding natural causes to natural events. Okay, science is not involved with the supernatural. Second assumption, evidence about the natural world can be gathered and experiments can be performed. Nature can be observed and data can be gathered. Questions concerning nature can be answered using experimentation, and then the data collected from that experimentation can be used to support or disprove claims or help answer questions or find out new things about the natural world. And then the third assumption, that nature is ordered and consistent. Nature has order to it and it works in a particular way that can be predicted. Okay? Now, there may seem like a lot of chaos in the world, and there is, but certain things about the natural world works in a pattern, in a cycle, consistently over a period of time. And that's what science is assuming in certain situations. All right, so predictions. So predictions are assumptions of science that assumptions of science allows for predictions to be made about natural phenomena. Scientific journals. These are what scientists publish their work in. Peer review. Okay, it's a very important vocab term when you're working on getting an idea past the scientific community. So before their work can be published, it must be peer reviewed, which means it must be reviewed by other scientists to test the validity of their work. Care is taken to judge each experiment to make sure it uses correct scientific method and is performed without bias. Okay? So this is why it's important for your experiments to be repeatable. Other scientists have to be able to repeat what it is you did to make sure that your methods were sound. What is bias? Bias is showing favor for or against something. There are two different types of bias. Number one is unintentional bias. This is when a person tries to be accurate but doesn't have the best information. Okay? Typically with unintentional bias, it's not on purpose. It's just for lack of information. Then you have intentional bias. This is when a person deliberately attempts to mislead others with information. Okay? So this person is 100% aware of what they're doing when they are presenting information or gathering certain information. So one way to try to prevent bias is blind trials and placebos. A blind trial is when information is concealed from the scientist, subject, or both in order to prevent bias. A placebo is a variable in a blind trial that is meant to deceive the subject to prevent bias. Okay, so a lot of times when scientists are doing blind trials, they'll hire a third-party company or third-party scientist that has no stake in the game, so to speak, of that particular trial to organize the groups and get things set up. And the scientist that is actually responsible for the experiment will not know which groups get what. The placebo is typically nothing more than a sugar pill. So that way, every group thinks they're getting something, and that group is told, especially in drug trials, that they are getting the drug when all reality they're just getting a sugar pill, which should not do anything. It's a baseline. Your placebo or your control group, your placebo group is known as your control group, and it gives you a baseline reading. So science's applications to the real world. So the first one is theory. Scientific theory is a well-tested explanation that unifies a broad range of observations and questions. Theories differ from hypotheses in that they represent an idea that has been tested. For example, the cell theory. A hypothesis is essentially a guess. It's an educated guess. A theory has been tested many times and is the best explanation for a phenomenon. So a theory has been through peer review. A hypothesis has not. Scientific laws. A scientific law is a description of how nature works. An example of a scientific law is Newton's law of gravity. It tells us how gravity works, what it is, and also how to calculate it. Scientific facts. Facts are information that is or are observable. So, for example, the bear is brown. Another example, birds lay eggs. Okay, we can observe those. Those are scientific facts. All right, so tying it all together, last slide. Theories, laws, and facts can be used to describe any natural occurrence. For example, the law of gravity states there is an attraction between any two objects in the universe determined by their mass and distance apart. A fact about the gravity is the force acts at 9.8 meters per second squared for objects on Earth. There are several theories about gravity that attempt to explain how it works. Okay, so using laws and facts and theories, scientists answer questions, long story short. All right, so be sure you complete the video form that goes with this one. And if you need anything, please let me know.